In this video, we will see about univariate linear regression, a fundamental building block in machine learning. It is a technique used to understand the relationship between one numerical value, that is independent variable, and another continuous variable, that is dependent variable. Imagine you are a data scientist studying the relationship between house size. House size is measured as square feet and house price. Univariate linear regression helps model this connecting using a straight line equation. The equation looks like this. Y is equal to b0 plus b1 into x, where y represents the house price, which is considered as dependent variable. X represents the house size, which is considered as independent variable. b0 denotes the y-intercept, the price where the house size is 0, usually not meaningful in the real world scenario, but we are considering. And b1 represents the slope of line, indicating how much the price tends to change with each additional square feet. The key here is finding the best fitting line for the data. We don't magically guess the slope and y-intercept. Instead, we use a method called least squares. This method minimizes the sum of the squared errors between the actual house price y values and the price predicted by the equation. The equation is framed based on the current slope and y-intercept. So, in simpler terms, we can say that it finds the line where the total distance between the data points and the line is minimized. Next one is evaluating the model matrices. So we have a fitted line, but how good it is, that is the main point. Here we use a few matrices to assess this performance. First one is R squared. This value is calculated between 0 and 1, tells us how well the regression explains the variation in house price. A higher R squared closer to 1 indicates a stronger linear relationship between house size and the price. Mean squared error, MSE. This metric calculates the average square difference between the predicted price and the actual price. A lower MSE signifies a better fit, as the error difference between predicted and the actual value as smaller on average. Root mean squared error, RMSE. This is the square root of MSE, which puts the error in same unit as the dependent variable, house price in this case. A lower RMSE indicates a better fit. So our ultimate aim should be RMSE should be in the lower value. And here in application, we are using univariate linear regression in many fields. But it has a wide range of application. Predicting future sales based on marketing spend, analyzing the relationship between customer range and purchase amount, studying the effect of temperature on crop yield, and some other important areas where we are using univariate linear regression is sales forecasting. In business and marketing, sales forecasting is the most important features in marketing. There we are using the univariate linear regression. And in customer lifetime value, that is to estimate how much revenue a customer can be expected to generate over their relationship with the company based on factor like initial purchase amount or purchase frequency. And some other example we can consider in science and engineering is crop yield prediction, like estimating crop yield based on factors like fertilizer amount and rainfall pattern or average temperature, etc. And in finance and economics, univariate linear regression is used in stock price prediction. For short term, it is not used for long time investment or something. For short term investment, it is used in stock price prediction. Loan default risk assessment, And also in demand forecasting, predicting future demand for a product based on factors like historical sales data or economic indicator. And also in healthcare and medicine, univariate linear regression is used to analyze the relationship between medication dosage and patient recovery rate to determine the optimal dosage. And patient risk assessment, assess a patient's risk for developing a certain disease based on factors like age, family history, or lifestyle habit. So while univariate focus on one variable, linear regression can handle multiple independent variable, which is called multivariate linear regression. This opens door to a even more complex modeling task. This concept is beyond the univariate regression that we will see in the next video in multivariate linear regression. Thank you.